Hello students, welcome to Soras's classes. In this video, I will be solving the following question from ISS 2017 paper 4. Now here we have to define the gamma distribution as failure time model and then discuss the monotonicity property of its hazard rate. Now first let us define the gamma distribution as a failure time model. Now consider we have this device. So suppose we have this device and this device is being subjected to shocks. This device is being subjected to shocks that are arriving in a Poisson process with rate of lambda. So shocks arriving in a Poisson process with rate lambda. Now suppose if this device it fails when it receives K shocks, that it fails if and only if it receives K shocks. Then this model it will lead to a reliability function belonging to gamma family. So this model it will lead to the reliability function belonging to gamma family or gamma distribution with parameters k and lambda, where this k it is an integer. So it belongs to a gamma distribution or gamma family with parameters k and lambda, where this k it is an integer. Now here it is that if this k is equals to 1, then this gamma distribution it will become exponential distribution with parameter lambda, and this lambda it depends entirely on the time scale. So lambda is the scale parameter, it is the scale parameter, whereas this k is the shape parameter. So this gamma function with parameters k and lambda, here k is the shape parameter which is an integer and lambda is the scale parameter. Now its PDF is given by this is given as f of t which is equals to lambda into lambda t raised to the power k minus 1 divided by k minus 1 factorial into e raised to the power minus lambda t, where this t is greater than 0 and k which is an integer is greater than equals to 1, where k is an integer and it is greater than equals to 1. So PDF or FT is given by this. So the survivor function that is ST, it would be given as 1 minus I k lambda t, where Thus ikx, this is equals to integration 0 to x lambda raised to the power k minus 1 into e raised to the power lambda raised to the power k minus 1 into e raised to the power, where ik is given by integration 0 to x s raised to the power k minus 1 into e raised to the power minus s into ds divided by k minus 1 factorial. So this ikx, it is given by integration 0 to x s raised to the power k minus 1 into e raised to the power minus s ds divided by k minus 1 factorial. So our survivor function st, it is equals to 1 minus ik lambda t. So the hazard function this would be equals to f of t divided by s of t. So this is equals to lambda into lambda t raised to the power k minus 1 into e raised to the power minus lambda t divided by 1 minus ik lambda t into k minus 1 factorial. Now this hazard function, which is denoted by ht, this is equals to lambda into lambda t raised to the power k minus 1 into e raised to the power minus lambda t, thus divided by k minus 1 factorial into 1 minus ik lambda t. So this is our hazard function. Now we can see that when our k, which is an integer, when our k is equals to 1, then the hazard function ht, it would be constant, and when our k is greater than 1, then the hazard function ht, it would monotonically increase. So this ht, it would monotonically increase from 0 at origin to maximum of lambda So this hazard function, its value would, when k is greater than 1, then the hazard function ht, its value would monotonically increase from 0 at origin to maximum of lambda. So this is the monotonicity property of the hazard rate corresponding to the gamma distribution with parameters k and lambda, which is defined as failure time model.